Hello and welcome back to my channel. So now I've made a new playlist on probability. So I will make some videos on probability in which I'll explain this topic in a much easier way, so you'll be able to solve complex problems after watching some of the videos. So let's begin. So first, in probability, let's see what is the meaning of an experiment. An experiment is any procedure that can be infinitely repeated and has a well-defined set of possible outcomes. Now an experiment can said to be random if it has more than one possible outcome, and deterministic if it has only one. Now in reality, we get experiments where we have more than one possible outcome. So let's see an example, like if I toss a coin, so the possible outcomes will be head or tail, so we have more than one. Or a second example, if I roll a die once, then the possible outcomes, or all the outcomes, will be those numbers from 1 to 6. We can get any number from 1 to 6 if I roll a die once. So this is the basic of an experiment. Now, the outcome, the set of all outcomes, is also called as sample space in the mathematical terms. Now moving ahead, we'll define what is an event of a probability. So the event is defined as the ratio of the number of favorable outcomes divided by total number of outcomes of any experiment. So let's say, the probability of any real event in reality is between 0 and 1, because the probability of 0 means that there is no chance of that happening. And then we have sure event where the probability is 1, so that means that event is going to happen 100%. So all the probability in the world actually is between 0 and 1. It can be 0, it can be 1, but it is not more than 1. So again, giving an example of rolling a die, we have, let's say we roll a die once. So what I want is, I want an event and I name it as E. So my favorable outcome, I should get an odd number. Let's say I want an odd number. So I want to see the probability of the occurrence of an odd number if I roll a die once. So we can see that the event E has 1, 3 and 5. These are all odd numbers out of the 6 possible outcomes. Therefore, so here the sample space are all those numbers. So the probability of E will be the number of items or number of elements in this space or in this bracket divided by the total number of outcomes. So here we can write it as, so the probability will become, here we have the number of outcomes. For our favorable outcome is 3, so we are getting 3 favorable outcomes or 3 odd numbers divided by the total number of outcomes, that is 6. Therefore the probability for this event will be 1 by 2. So now moving on, we have to okay, so now let's talk about algebra of events. So here I have already drawn a die. So let's see, first we'll understand a complement of an event. So let's take an example. We'll give an example of a die. We rolled a die once. So this time we need the occurrence of an odd prime number. So the total number of outcomes are 1 through, the 6 part. There are no 7 numbers, so let me just remove this one. So 6 total number of outcomes. So our event, or the outcomes in our event, are 3 and 5. These are odd prime numbers. They are both odd and prime. So let's say, so E dash, let's denote E dash by a complement of an event. So what it actually means is, complement means the opposite of what we have just got. So our actual event E, we had 3 and 5. So the remaining outcomes are known as the complement of this event. These are the opposite, or so that's why 1, 2, 4 and 6 will be the complement of event E. So let's now go on to the union of an event. So here again I'll give an example of a die. So this time we need, or let's call E1 the event. We want an even number. We want to find the probability of an occurrence of an even number. And again we have another event, we want a prime number. So E1 we have even numbers 2, 4 and 6. So event E2 we have 2, 3, 5. These are all prime numbers. So what is the union of those two events? The union mathematically is defined using this symbol E1 and this symbol of U, which is a union. So this is simply a cumulative of all the numbers, or just collecting all the numbers from E1 and E2 and grouping them together to form a new sample or new set containing all those numbers. So again we have 2, 3, 4 and 5, 6. So here we can see that 2 is occurring twice. We don't write it twice because it's the same number, so that's why we write it once. So therefore now we understood the union. So let's now move on to the intersection of an event. So again we give an example of a die. Let's say E1 we want occurrence of an even number, and another event we want the occurrence of a composite number which is not prime, numbers other than prime. So E1 will be 2, 4, 6, and E2 are 4 and 6. So the rest of the numbers may be prime, not prime numbers. So because we know that 1 is a prime, and 2 is a prime, and 3 is a prime, and 5 is a prime. So all those numbers are prime, but 4 and 6 are not prime because they are not divisible, not only divisible by 1 but also divisible by other numbers apart from 1. So let's say what is the intersection of an event. So in this case the intersection of E1 and E2 will be finding the numbers which are common in both of them. So we can see that 4 and 6 are common, therefore the intersection, or E1 intersection E2, will be 4, 6. Now again let's find the probability of E1 intersection E2. So probability here, I can say that the probability will be the number of events, or sorry, number of outcomes in E1 intersection E2 divided by total number of outcomes, or let's say sample space. So again we have two numbers divided by sample space is 6. It comes out to be 1 by 3. Even in the previous example that are given of the union of an event, so here the probability of E1 union E2 will be finding the numbers in union. There are 5 numbers or 5 outcomes, and the total number of outcomes is 6. Therefore the probability of E1 union E2 is 5 by 6. So moving on, here we move on to the next slide. We understand, let's see, equally likely events. So equally likely events are said to be equally likely if probability of their occurrence are equal. So again, so the second one, we have mutually exclusive events. So these are events where any given events, they have nothing in common. So if we select any two events, they have nothing in common, they are called mutually exclusive events. Also their probability or the intersection, the probability of their intersection is 0. So third one being exhaustive events. So here again, if we have two events and if we find their union, and if their union is equal to the sample space, or in simple terms, the union constitutes all the outcomes of the sample space. So therefore the probability will be 1. A union B, the probability will be equal to 1 because it is equal to the sample space. Now moving on, some questions. So here we have the first one being, a pair of dice has been rolled once. Find the probability that at least one of the die shows up the face of 1. So first what we can do is, to make it easier, we can find the probability of die where none of the face shows up the face of 1. So that means we are getting all the numbers except 1, so we are left with our event E will be for the 1. First die is 5 by 6, right? We have 5 numbers apart from 1 and 6 being the total sample space. And again for the other die, as they are rolled together, so again we find the probability that none of the number is 1, so again the probability will be 5 by 6. So here the cumulative probability of both of them will be 5 by 6 into 5 by 6. So this gives the probability that none of the dice shows up the face of 1. So automatically if we subtract it from 1, that means we get the probability that at least one of the die will show up the face of 1. So therefore the answer comes out to be 11 by 36. So we have, out of 36 outcomes, we have 11 outcomes where the either die is showing the face of 1. So let's move on to the next question. We have, a natural number is selected at random and it is squared. What is the probability that its unit digit will be the number 6? Okay, so let's begin. So first let us write down all the natural numbers from 0 to 10. Unit digit, so we know that we have to write from 0 to 9. 0, 1, let me write down, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Sorry, the 10 won't come because the only single digit number will be at units place, so therefore we have a single number. So if we square all of them, let's square 0. So when we square 0, again we'll get 0. If we square 1, we'll get 1. If we square 2, we'll get 4. And likewise we'll get 9. We'll get 6. At the here the 4 square is 16. Therefore at units place we have 6. So here we get 5. Here we get 6, here we get 9, here we get 4, and here we get 1. So these are all the numbers at the units place. So the question is asking, what is the probability that the number will be 6? So here we can see we have, out of 10 numbers, we have the total sample space is 10, right? So here we are getting two numbers that are 6 out of 10. So therefore the probability will be, so we can write the event. We have got E1 is 6 and 6, right? So we have two numbers, so there are two possible outcomes, favorable outcomes. Therefore the probability of getting a 6 is 1 by 5. Okay, so now move on to the next question. This is the last question. So what is the chance that the fourth power of an integer chosen randomly ends in the digit 6? Again, we have to simply square the unit numbers twice. So let's write that again. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So when we square them twice, so let's see what we'll get. We'll get 1, we'll get 4, and we will get 6, 3, 9 and 1, 6, 5, 1 and 8 will get 4 and 6 and 9 is 1, 1. So again we need to find the digit 6, how many times does it occur. So here we can find first time, second and 3 and 4. So we have total 4 times that the number 6 occurs after squaring a unit number twice. So we have 4 outcomes out of possible 10 outcomes. So therefore the probability will be 4 by 10, which is equal to 2 by 5. So that's it for this video. In the next video we'll go on to more little bit advanced topics in probability. So thank you for watching.